My name is Matt Baker. I'm a faculty and researcher here at the Friday Harbor Labs at the University of Washington. And behind me is the Cyclops 1, which is run by OceanGate and with the Sea Dock Society. And we're going to take that out tomorrow to build on some of the research that we've been doing in this area. And that is that we've been looking at Pacific sand lance. It's a forage fish. It's important to the ecosystem. Just about everything eats it. All the birds, all the marine mammals, most of the fish species. And we have a team of physical oceanographers and biologists going out to dive down about 80 meters, about 3 kilometers here, do a transect over a submerged wave field made up of sand, and look at how the tides are shifting that sediment through different tidal cycles, and then also to look at the fish that reside within that sediment field are responding both to us and to tidal cycles, and what are the cues that make them leave that sand and actually go up into the water and feed, and then they're able to not only feed, but they're available to all the predators that are taking advantage of that resource.
Hi, my name is Cressmer Williams. I work at the Alaska Fisheries Science Center at NOAA in Seattle, and on this particular project I brought this stereo camera along to put on the sub, and what this unit does is it basically takes still images, a pair of still images at whatever interval we specify, along with a strobed light. And from these images we can actually get a lot of information, quantitative information about what's in front of the sub. We can measure fish to a very precise length. We can also do a full 3D reconstruction of the visual field in front of us. It's basically using the same principle as your eyesight, and having basically 2 cameras that are offset, giving you that different perspective. You can actually solve for the full 3D space by doing some analysis. So these are calibrated units, and in this case their original mission was to go by themselves and be the standalone units that were deployed, but we've been sort of started using them in a variety of applications. We've had one on an ROV before, but this is its first trip on a actual submarine.
I'm Aaron Galloway, and I'm a co-PI on the Urchin project.
I'm Alex Lowe. I'm a graduate student at the University of Washington, and I'm co-PI on a project looking at red urchins and their use of drift kelp.
We've had a number of years of working on nutritional subsidies, basically the flow of energy from shallow subtidal kelp forests down to deep water urchins. But what we used to really call deep is just as deep as we could dive, which is like 33 meters basically. And so we've been interested in this subsidy of algae to deep urchins for a while, and we've studied it we've done some stuff with ROVs and with trawls, but this is kind of like the first time that we've ever had opportunity to actually look at urchins in really deep water.
We got in the sub and went down, and it was so cool to be in the sub as the water was bubbling up around it, and it was really peaceful in there. And just watching the light change was very cool, and there was little fish and all sorts of crustacean and zooplankton on the way down, and then basically our second glimpse of the bottom, there was a red urchin at 284 meters, which is more than double the depth that anybody has ever seen them before. And so it was mission accomplished in 6 minutes. Like we had seen that at least the red urchins, which are dependent on kelp, can live to 950 feet.
We got to see an octopus in a standoff with a lingcod, and this octopus, it was all like its skin was all textured, so like points were sticking out, and it was completely out of its hole, and like the current was blowing its head back like hair in the wind. It was like they were about to battle it out, and we were like so we got to see that for, you know, a full minute before we drifted away, and yeah, that was amazing.
And we got to count stuff today in the last couple days. And right here is the record. This is the moment when we noticed the deepest urchin ever recorded in terms of this species for red urchins. So that's really cool. That's something that this gave us an opportunity to do. We have now expanded the depth range of this species.
My name is Pema Katayev, and I got to go in the sub as part of Team Echino this week. And I'm not a student. I work here at the labs since 2005. I am the dive officer. One thing that impresses me most about your operation is your protocol of having the 5-minute stand down before the final deployment. I really like the whole atmosphere and culture of not feeling urgency and not feeling a lot of rush. I felt it was very calm and orderly the way the operations proceeded, and that's very comforting to everyone involved, even the people who are enacting it, to know that they're in that much control and they're not feeling rushed.
So going down in the sub allows us to look for how these animals are interacting with each other. We're also looking to see if we're leaving a mark on the seafloor when we do those trawls. So one of the things that we're looking for is whether or not we see any evidence of that scientific trawling that we've been doing over the years. And we haven't found any evidence yet. We're going to go look tomorrow and see if we see any also.
That we picked 3 proposals to do in this week, and not only did we get all of the dives done, we got 2 extra dives done, and we ended up with good science on every single one of those 3 proposals. There is some cool take-home message from each of those. That is super hard to do with a huge amount of planning and pilot data. This was the pilot data, and so as a scientist, I'm kind of blown away by it. We felt like pampered rock stars. Scientists are not used to that. We're used to sleeping in the mud and eating canned beans. And this was just a delight. And it was wonderful just to be able to think about the science and really blue sky ideas that never would have come up otherwise. So from the bottom of my heart, I thank all of you OceanGate folks and for putting it all together, Joe and Neil. So thanks tremendously, really.